Okay, we are going to be talking about method 3 and how to factor trinomials that look like this. So we're going to go way back and look at some of the old examples from chapter 4 where we got things that look like that. So like x plus 4, x plus 5, and we multiply these guys together and we have x times x gives us x squared. Then we have plus 5x. Then we have plus 4x plus 20. So we got x squared plus 9x plus 20. Then let's try another one. X plus 3, x plus 7. So we multiply it and we get x squared plus 7x plus 3x plus 21. 7 plus 3 is 10. You get x squared plus 10x plus 21. As you do many of these, and you guys have done a ton of them, you start to see a pattern. Such where if I had x plus 2 and x plus 9, some of you could do it in your head, and if you can't yet, try looking at the pattern of where these numbers come from. Now, this is x squared plus 11x plus 18. Double check, we have x times x gives you x squared, then a 9x and a 2x, that makes the 11x, and then 2 times 9 is 18. So we start to see something really kind of cool that comes up here, that the 2 and the 9 add together to give you 11, and then times together to give you 18. Notice what happened here. We've got the 3 and the 7 that add together to give you 10. The 4 and the 5 add together to give you 9, and times together to give you 20. So, when we have something that looks like that, say x squared plus 11x plus 28, what we really have to do in order to go backwards is find out two numbers. We know that an x here and an x there, but we've got to find two numbers that multiply to 28 and add to 11. Some of you will be able to pop that out and be like, oh yeah, those are they. Some of you won't. So for those of you that can't, go ahead and take the number 28 and write down all the factor pairs. So we're not doing prime factorization with the trees, but we're writing down all the pairs that will times to 28. 1 times 28, 2 times 14, and 4 times 7. You're like, hey, which one of those guys adds to 11? Oh, right there. We have a plus 4 and a plus 7. We get x plus 4, x plus 7. And this is it. This is how we do it. We're going to call this method try, for trinomial, fast. So it's just a matter of taking this and breaking it up in one step. Let's try another example. X squared plus 11x plus 30. Let's try that one. So in breaking it up, we know that since that's an x squared, we had an x and an x. And now all we need to do is find two numbers such that they times to 30 and add to 11. So if we come over here, some of you can see it right away. Others may have to write this down and say, oh, that's 1 and 30. Let me see, 2 goes into it 15 times. 3 goes into it 10 times. 4 doesn't go into it. 5 goes into it 6 times, and 6 is the next one, which we already have. Like, okay, what does that? Oh, look at that, 5 and 6. So plus 5 plus 6. And you can check this out. X squared plus 6x plus 5x, there's your 11x, plus 30. Alrighty, let's try another one. X squared plus 2x minus 15. Same thing, we're going to take and break it up with the parentheses, and we have x here, x there, and now we have to times something that equals a negative 15 and adds to a positive 2. Now think about the things that times up to 15, a 1 and a 15, a 2 and a 3 and a 5. So this we'll have to do x plus 5, x minus 3, and those two do in fact add to positive 2. So we're going to have to watch negatives like crazy here. Let's do another one like that. X squared minus 3x minus 40. And you look at that, and again, I'm going to put a negative 40 over here, and let's write down the factor pairs that would work. 1 and 40, 2 and 20, 3 doesn't work, 4 works, 4 and 10, 5 and 8. Oh, now those will add. Now if it is multiplying to a negative 40, then these two have to be opposite signs. So like a negative 8 and a positive 5. Now if you get them backwards, they would add to a positive 3 instead of a negative 3. So you got to watch that. So this is going to break up to x plus 5, x minus 8. And you can double check that that is correct. Alright, so now I'm going to give you 4 of them, and they're going to look very similar, but I want you to look at these and then stop the video and then give it a shot. X squared plus 10x minus 24. X squared minus 10x minus 24. X squared plus 10x plus 24. X squared minus 10x plus 24. Okay, we got all 4 different options here. Indeed. So all of these are going to have stuff where we're going to try timesing up to 24. So I'm going to put that over here and write down the options. 1 and 24, 2 and 12, 3, 8, and 4 and 6. Now notice that this option, if they're opposite signs, timesing to a negative 24, will add to 10. And this one, if they're the same size, will add to 10. So go ahead and turn off the video for a minute and give those a try and see if you can match up the right numbers with the right problems. I'll give you just a minute. Okay, so if you've done it, let's give it a try and see if you got it right. It's going to be x plus 12, x minus 2. That's a plus 12 and a minus 2 that times together to give you a negative 24, and then add to a positive 10. And over here, we're still timesing to a negative 24, so they have to be opposite signs. This is x minus 12, x plus 2. Now let's be very clear on this. Some of you may have written x plus 2, x minus 12. You're like, isn't that right? Well, yes, it is. These two are the exact same answer. This is just the commutative property of multiplication of that one, where you just switch them places. So let's get rid of that one, but if you get any of the answers where it's just the 2 factors switch places, then yes, it is exactly the same thing. So this one down here, they're the same sign, and so we're going to be using a 4 and a 6 to add to 10. So this is x plus 4, x plus 6. And this one down here, same thing. They still have to times to a positive 24, but this time they're adding to a negative 10. So we have x minus 6 and x minus 4. These are the only solutions that would work for that. Okay, let's do one more of those examples. We'll write up 4 more that are very similar. X squared plus 13x minus 30. X squared plus 13x plus 30. X squared minus 13x plus 30. And x squared minus 13x minus 30. Go ahead and pause the video and give those a try. We'll be back in just a bit. Good, now that you've given those a try, if you haven't, pause the video and go and do it. If you have, let's look at them. They're all dealing with 30, so I'm going to write 30 over here and say, oh, we got 1 and 30, 2 and 15, 3 and 10, 5 and 6. Is that right? Notice there are 2 of them, again, that could possibly add up to a 13. If these 2 are opposite signs, we could get a 13. If these 2 are the same signs, we could get a 13. So here, they've got to be opposite signs, or in other words, the 2 will kind of subtract 13. So we're going to have an x plus 15 and an x minus 2. Over here, they've got to be the same signs, either both positive or both negative, and they've got to add to a positive 13. So we're going to be using that one with a positive and a positive. X plus 3, x plus 10. Good. Here we've got x minus 3, x minus 10, and then on the last one it's a negative, so we're going to be back up with the 2 and the 15, and that's x minus 15, x plus 2. And just to make sure everybody's clear, you could mix these up by the commutative property of multiplication. You can switch things around. X plus 10, x plus 3 is going to get you the exact same thing, or in this case x plus 2, x minus 15. Okay, you're ready to do all of the problems that require you to use method 3 on anything that starts off with just a simple x squared.